quickly as possible. I want to show you something though. This took some time, but I think this is going to be very helpful to you. If you go to the Algebra 2 page, I've done something differently here. If you go to the Chapter 5 instructional videos, look what it does. Okay, it pops up a playlist. It goes to a playlist on my YouTube page. And I renamed these things so they're descriptive. They really tell you what they are. So if you go down and you look at these, they're in order. So it starts like with 5.1, graphs of quadratic functions, and then it gives you the date that we did this in class. And it just goes all the way down through all the stuff we did in class. And it's all organized. It's in order. It tells you what section it is. I'm sorry, question? All you have to do is go to on the home page, Algebra 2 homepage, just hit that link, chapter 5 instructional videos, and it'll take you there. And so I think this is my effort to try to where is that? Yeah, and to give you a resource. If you look at all the educational research in the brain science says that really the best thing you can do is, obviously a really important step is the first time you see it in class. But there's a lot of information, and it's relatively complex stuff, and so you can't ever hope to just get it all at once. Those days are gone in math. You got to look at it multiple times to get it. And so what the brain research all says very specifically is that if you can go back to the environment that you were in when you were learning it, it really helps to pick up where you left off. And so this is the best of all possible worlds for that, because not only are you seeing, when you look at this, you're hearing my voice and you're seeing the same stuff that you saw in class. You have the ability to, in YouTube, you can pause these things, you can rewind them, and these, looking at this from kind of a student perspective, I think this is a lot better way to do it than the way I had it before, because those little embedded pop-ups that I had, the idea was I was going to try to, like if I pull one of these up, some of them have no audio, unfortunately, and I try to avoid that, but every once in a while it happens. Like if I pull this guy up, yeah, I tried to avoid having all this stuff over here, but you guys, if I do that, you don't have as good access to, like here I can go to the full screen, and I get this full access to this slider down here, and look at this, I get these little thumbnails I can look at as I go. I'm kind of standing in the way, but I get these little thumbnails, so you can even kind of pinpoint where it is you want to go probably, what part didn't you get, and just go there. Right? You can pause it, you can do a problem if you want to, you can go back to something. This is a good resource. This is something that I hope you take advantage of.
How much free time does this take?
This takes too much. I'll tell you what, too much. But I do think this is something that I thought it's worth spending a little time on, because I think it'd be so valuable to you. Anyway, it's there. Take advantage of it. I think, to me, if I were in your position on this stuff, I think what I would do is I would probably not spend nearly as much time on the PowerPoints as on the YouTube videos. I think the PowerPoints are fine. If they're useful to you, I'm not going to tell you how to study, but to me,
I like the YouTube thing better.
I think the YouTube thing is a lot better. I really do.
Way better.
So, all right. So now I'm going to get going here so we can get you down to the lab. Come on, where are we here? Here's where we left off yesterday. Okay, so let's just pick up here. Now you guys did a great job. We're further along than the other class. I think you're going to get a lot more lab time today than they will. We left off doing just finishing up the non-graphing calculator review, and the last few problems, a lot of them had to do with arithmetic with complex numbers. Okay, this is the one that's the hardest. We did the easier stuff yesterday, the multiplying and adding and subtracting. The dividing part is a little tougher. So let's maybe take a look at one of these. So if I'm going to do this problem here, 12 plus 13i divided by 14 minus 9i. And the goal here is to write this in standard form. So we want to get our answer to look like a plus bi, right? So we need to, what's our strategy here? How do we get rid of that complex number on the bottom? Okay, good. We're gonna multiply, our trick is multiply top and bottom by the complex conjugate of the bottom, meaning the conjugate of that complex number. So that's gonna be 14 plus 9i. Okay, and if I do that, right, if I do that process, you've done this enough that you've probably kind of figured out all the shortcuts. The bottom is easier than the top here, isn't it? What we always find out on the bottom is that when I FOIL this out, remember that the first times the first gives me a number, so 14 squared is, what is that, 196?
Yup. I knew that in my head.
And then when I do the other parts, I'm going to do the 14, the outside, 14 times 9i gives me an answer, but the inside, 14 times negative 9i is going to cancel it. So don't even bother with those. Don't even bother when you're foiling this out with the O and the I. All you need is, you're just foiling it, not foiling it, just the first and the last. 14 times 14, and then I get last, negative 9i times 9i is minus 81 I squared. But what is I squared? Negative 1. When we see an I squared, remember all we do with that is it just means that we're going to change the sign of the coefficient to a plus in this case, right? So the bottom's easy, no big deal. Top, we got to take a little more time with. Top is a little bit more time consuming. If I FOIL this one out, 12 times 14 is 168. Plus 9, 12 times 9i is 108i. Plus 13i times 14 is 182. There you go. I plus, that's going to be 108 plus 9. That's going to be 117. There we go. Good. 117.
He's doing this in his head.
I squared. Okay. And what's the I squared do up there? You know, obviously same thing as before. So that's going to change this to a minus, right? And then we end up with, if we combine like terms, that's going to make that a minus 117. So what am I going to get when I combine like terms on the top for my real number part? What's 168 minus 117?
Small number.
Yeah, 51.
I think so.
Okay.
Not really smart.
But we got to combine these also, right? So 108i plus 182 is 290.
Yeah.
290.
I, good. Divided by 196, but remember, that's going to make that a plus, isn't it? Right? That I squared is going to turn that minus into a plus, right?
77.
And so we get, good, we get 2.
Sure you were. Seriously, I got the
277, okay? And so if we want to write this then, last step, we're done. We want to split this up into two parts. We want to split it up into a real number, which will be a fraction, plus a real number times I, right? And so I get my A is just going to be 51 over 277. My B is going to be 290 over 277 times I, right? And what did they ask for here? It could be either one. In this case, they want the complex coefficient, B, right? So what's B?
Isn't
290 over 277.
Yeah, good. It's the number that is in front of I. It's being multiplied by I. And they want this as a decimal, so we would just throw that in our calculator and get a decimal answer, rounded to two places. Okay? All right. Moving on. Last one, I think, on the non-graphing part. They want us to find the greatest real solution or the complex solution with the greatest imaginary coefficient. Okay, so looking at this problem here, yeah, this is clearly quadratic formula, isn't it? There's nothing, I've got 7x squared minus 5x plus 15 equals 0. Let me rewrite that a little bigger for you. Unfortunately, I can't divide both sides by anything to trim this down. I'm kind of stuck with that the way it is. So this is obviously a quadratic formula problem. We do not want to try to factor this because we'd have to do the a times c then split b. And you know, this is where I gotta fess up a little bit. When we do this stuff in a math, you know, introductory math class, algebra class, or algebra 2 class like this, and we're trying to learn the techniques, you know, you have to kind of handpick the problems to even work if you do it that way. Think realistically here, in kind of a real life setting where you had to do something like this. What are the odds that the numbers are going to work out just so that you're going to get a times c then split b that even works? Odds are more often than not, it's not going to work out, right? More often than not, the answers you get are not going to be nice, even answers. They're going to be irrational or fractions or decimals. Yes?
What times in life are you use the quadratic formula?
Use the quadratic. Well, I mean, you know, no, it's I guess there's different. I mean, yeah, if you're a mathematician, sure. If you go into any kind of a field that uses math, even peripherally, where it's not even the main thing, you do some stuff like this. I use this stuff. I mean, there's some practical things. I mean, that's obviously not why we're doing this. But if you're, I mean, I use this stuff. If I'm building a shed and I want to, you know, I need to figure out how much roofing to get or something. If you know how to do math, it makes it pretty easy to do. That's not why we're here, but there are lots of applications.
You just build a shed.
Well, I mean, I roofed a shed last summer, and I had, you know, I didn't want to buy too much material, and so I mean, yeah,
Were you
it's.
using the imaginary number?
No, I wasn't using imaginary numbers. I wasn't using imaginary numbers.
3xi right now. I want that much material.
But there are things that you'll run into where, in your preparation for your careers, where you'll have to use this stuff. So, okay, so let's go ahead and do our quadratic formula stuff here, right? So we know x equals.
Negative b
Plus or minus square root.
Oh, I know this one. Divided by 2a. Only
She's
part
singing it back here.
AC.
She's singing it.
Mine 2a.
Yeah. The only part I know.
Jeez.
You'll never forget it. You just remember that little song. You'll always be there.
She's singing it back here.
Okay, so now for our situation here, let's identify, and what I would do for these problems, at least until you get real good at this, I would write this thing out every time, and I would write out for yourself what are the values of A and B and C, so you can't make any mistakes.
7.
B is,
-5.
C is,
42.
no, 15. Okay, so now, a couple things. I know this part, you're probably thinking, I know this. Most of you know this really well, but there's still some places where people continue to make a few mistakes. Remember, can A, when we're doing the quadratic formula, do we
No.
want A to be negative?
No.
No, we don't. If it's negative, multiply both sides by -1 and make it positive. The other thing is, when we're doing the quadratic formula here, here's the other thing. I still see people making this mistake. Don't resist this. When I square B, if B is negative, make it a
Make it
positive,
positive.
right? Because there's still, every day I see several mistakes on that one where people plug in a -5 squared into their calculator and it tells them the wrong answer. So
What?
So if we plug this stuff in, we're going to get negative B is 5, right, plus or minus square root of 5 squared.
Minus 4 times 7 times 15.
Good?
Over
2
2
times
times 8. We'll just make it a 14, okay? So now all we got to do is just simplify this. That's it, right? In fact, all we really have to do is put this in our calculator. But, I mean, if we wanted to just make this one step simpler, x would equal 5 plus or minus the square root of. Now, what is this all going to be? Here's the discriminant, right? Let's look at that value. What is 5 squared minus 4 times 5 times 15? Well, that's going to give us, the stuff in this circle is going to be 25 minus, oh gosh, what's that going to be? Oh, man, I don't really feel like doing it. 4 times, this is the easiest way. 4 times 15 is 60, right? 60 times 7 would be 420. So that would be negative 395.
Really, Dan?
See, and then he uses like your email.
Okay, so what are we getting out of this then?
Oh, we're trying to find the greatest, aren't we?
We're trying to find the greatest, but do we see a red flag here? Or a red negative sign.
Negative.
So what are we getting if we have a negative inside a square root?
Aye.
Good night. Okay, so our answer then is gonna look like 5 plus or minus. Right, and we're gonna take the plus, you're right. I times the square root of 395 all over 14. And we're just gonna take the plus one, right? We'll just take that guy. And that's our answer. We don't really have to do anything fancier than that. We just know that we're gonna get 5/14 plus the square root of 395/14 times I. And do they want the whole thing, or they just want the, what do they want here? Find the greatest? Okay, so they want the whole darn thing. So how do we put that in Moodle? Last step.
5 by 14.
Don't even need the parentheses, just 5/14 plus.
Plus square root of 5. Right?
Okay, I'm gonna pause here for a second.
Quiet, Jack.
Okay, plus squirt 395 divided by 14. Then all I have to do at the end is just do my times I. And if I do all that stuff, assuming we didn't make any mistakes there, that's what we see, right? How about that?
I can do that.
Okay. All right. Okay, shifting gears. So we're getting there. There aren't very many of these to do. The graphing calculator review questions. It was a shorter review, and it was very clear which ones people were having trouble with. So this was one, and I think the only reason people had trouble with this is they just weren't sure how to interpret the question. So let me pull up the graphing calculator. We'll just do everything on here now. If we want to find the maximum, all we're doing is we're going to make a graph of this thing. Quentin, we're going to make a graph of this thing, and we're going to find the maximum value means the y value. We're talking about the value of a function. We always mean the y value of the function. So if I graph this guy then, okay, so we'll just go up and graph negative 15x squared plus negative 2x. We could just make a minus 2x, right? Minus 2x plus 6. And I'll start off just going zoom fit. It may not work, or zoom standard, sorry, zoom 6. It may not work, but we'll see. Maybe it will. Well, that's not bad. Not bad. I could. What's that? Say it again. If I hit zoom 6, in this case it'd be a real bad idea, because what zoom 6 is going to do, zoom 0, zoom fit. If I hit zoom fit, it's going to fit this parabola so the whole thing fits on the screen all the way from x equals negative 10 to x equals positive 10. Can you imagine how far down that parabola is going to go if I go clear out to negative 10 and positive 10? We don't want to do that. Now, one thing I could do, though, real quick, that might make this a little easier to navigate on, that just takes a second to do. Put that phone away in your pocket, or I'm taking it. If I go to Window, and I go make my x's, instead of going from negative 10 to positive 10, why not go from like negative 4 to positive 4? So all I'm going to do is instead of looking at that whole thing, I can just make the parabola a little bit wider, right? By having the window not cover as much ground horizontally. If I just hit graph then, it just makes it a little easier to move around on the parabola. All I need to do is find the maximum. So if I have a question of the graphing calculator, all I ever do is second calc. You're right. So second calc, which one do I want? Maximum. Okay. And then I just have to trap it. Left boundary, I'll go over to the left of the peak a little bit, the maximum. Right boundary, I got to go over to the right of the maximum a little bit. So about there-ish. And then my guess, I'm just going to put it somewhere, sort of close to the top. Doesn't need to be right on the top. And it tells me I'm looking for the y value, right? And so the y value is going to be rounded to 2 decimal places, would be 6.07, right? That's my answer. Okay. Just based on the graph. Okay, make sense?
Uh-huh.
Okay, no big deal.
Easy squeezy.
Here, okay, projectile motion one. They want to know, and these on the test, these could be different. They're not all going to be on the way up or way down. It might ask you for the maximum height or how long it's in the air, and you know, in this case, they wanted to know if a projectile is launched vertically from the ground, after how many seconds will the projectile be at a height of 196 on its way down? So all we're going to do is make a graph of the height versus time parabola, right? And we just want to analyze that. So, go back to my calculator. Here's the function we're putting in, right? So negative 16. Instead of t, we're going to use x. X squared plus 417t. So 417x. Okay, let's go ahead and graph this one first, and we'll get this graph looking nice, and then we'll do the rest. Because this is the hardest part of the whole thing, is just getting this thing to appear on the screen so we can see it well. How do we do this, you remember?
Zoom 6.
Well, if I go zoom 6, it's going to be way off the screen.
Zoom 0.
Okay, I'm going to end up doing zoom 0, but I got to set the, I got to pick the x parts I have to sort of pick, and I'm starting off by just guessing. So if I go to the window and I'm going to set the t's or the x's, what do I want to start with for a problem like this?
Negative.
Now think what it means. This is how high the projectile is as a function of time. So what's a pretty obvious starting place for this whole problem then? 0. Yeah, that's when the thing gets launched, right? Nothing happens before 0 that we're interested in. So x min is going to be 0. Make a guess. I mean, literally, just make a guess. How long do you think it's in the air?
500.
500 is going to be too much. I'll tell you that right now. Okay, we can try that. We'll try it. I think we're going to be a little high, but we'll just try it.
I find that.
If I do 250 and I go, now I can go zoom 0, zoom fit. Yeah, that's a little too much. You can see that we don't even see it go up, it's so much. So we gotta scale that down quite a bit. Let's go up to the window and how about if we start off with like 50 instead?
62.
Better number.
Let's try that. We'll go with 50, zoom 0, and we still are probably gonna have to adjust this. That's still too much, but we can get a good guess now. If that's 50, 25 looks reasonable, doesn't it? Right? So if we go up to window,
30.
25, and I think finally we're gonna probably get this thing. Zoom 0. Oh, look at that, right on the money. Okay. Well, close enough. Maybe close enough. We wanted to find when this thing hits 196 on its way down. I think we better scoot that over a tiny bit. Instead of 25, we probably want to go over to like 27 maybe.
30.
That's gonna work right there. Okay, everybody agree? Good enough? Okay, now if we wanted to just find the maximum height, all we do is what we did last time, right? Just find maximum. If we wanted to find out how long it's in the air, we could just find out where y is 0 there. We could find the 0 of the function. But they want something a little harder. They want to know when it hits 196, a height of 196 on its way down. So what was our trick? If we want to, and this works not just for projectile motion problems, but on a calculator, if you want to use a calculator to find the x value, or t value in this case, for a given y value, a specified y value, we have a good trick for that. What do? Graph the y value, because that's going to give us a horizontal line at that y value, right? So we'll go down to 196, is that what it was? 196, I'm just going to hit graph, because I've already got the window set. And I can see there's where it hits on the way up, there's where it hits on the way down, that's what we're looking for. So I'm going to go second, calc, what do I want? Intercept. And then, is the first curve y1? Enter, yes. Is the second curve y2? Yes. Now I have to go make a guess though, so I'm going to trace over until I get close to that intersection. Okay, and that's probably even close enough. But if I had the cursor over here too far, it would have picked this guy instead.
If you just keep hitting enter, it picks the other one.
Oh, it does?
Yeah.
Oh, good to know. Okay. Really? I never knew that. Okay, so there's the first one. That's the one we want. So it's 25 point, the 2 decimal place is 25.58, right? And what Amanda's telling me is if I hit enter again,
Whoa.
it does it on yours?
No, when I first set up and choose intersect,
Mm-hmm.
first,
She
second,
just has to
third,
enter
and
3
then
times.
first one. Yeah.
Like she doesn't have to move.
And it'll pick the other one the second time you do it?
Yeah.
Oh, really? I had no idea. Well, that could save you a little time.
A lot of clicks. Click. Click.
It didn't do it for me. I'm not sure about that.
Just did it.
Yeah.
Yeah, look.
Well, yeah, but it still gave me this one.
That's the one you wanted.
I know, but I'm saying I had to, I thought we were talking about something different. I did have to trace over there for my gaps.
Oh.
I thought people were telling me you didn't have to do that, but I think you do.
You don't.
Yeah, when I first pulled my graph up, I just hit enter 3 times, and it gave me the first intersect, it gave me the middle, and then it gave me the.
I'll have to explore that a little more. Before I'll endorse it, I have to know what it's doing. If that, I'll check it out. If that works, I'll show it to you. Okay, so
This is easy. 2 left.
you know the other thing that could be happening there is remember that this calculator isn't. I can't update it, so maybe the new operating system is better at that than this one. That could be. Okay, so last couple problems for the quadratic function in intercept form. Y equals, and let me write that down for you. Remember, intercept form is
Boy, for the
y
test.
equals a times x minus p times x minus q. We want to fit this thing to that form for the one that passes through the points -4, 0, 6, 0, and 2, 16. Thank you. Oh, gotcha. Okay, thanks. Where's Sheena's? Okay, so what's our trick? What's our trick with this? If we want to fit this thing, say it again. Okay, so we got to recognize what the parameters are. Our goal is just to fill in. We want to turn all these into numbers. Do they give us any freebies? Yeah, they do. Right? They tell us that one of our x-intercepts right there is 6, 0, right? That's telling me that when y is 0, x is 6. So that's p. I could plug that in right there. 6 is p, right?
Does it matter
This-
if it's
oh, I got it backwards. Doesn't matter. Doesn't matter. So this one over here, actually that one's q. You're right. This one's p.
Why? Why does it matter?
It doesn't. Here, let me go back. It doesn't really matter. So this is an x-intercept, right? So we'll take the one on the left to be p. It doesn't honestly matter. So -4 goes in for p. This is an x-intercept. So 6 goes in for q. But that still leaves us having to find a, right?
You have to put 2 in for X.
Okay, good. And that's where we can plug in the 2 and the 16. And what it's asking for is the value of a,
That's easy.
right? And so if I plug in 2 for x, now 2 for x means I got to plug it into 2 places. I got to plug it in there and there. And 16 is y, so that goes clear over to there. Now, if I plug all that stuff in, would you agree I've plugged numbers in for everything except a? Okay. So then all I have to do is solve for a. So 16 equals, just get, a times x is what, 2 minus -4 times 2 minus 6, right? Simplify,
Yes.
just turn those into numbers. So 16 equals a times 6 times -4, right?
And that is.
So 16 equals -24a. So what's a?
You divide by -24.
60.
So a equals -1624, which would reduce to
Half point. Wait.
2/3.
Yep.
Yeah.
Because you're.
It wants it as a decimal, I'm sure, so, right? And it wants it to how many decimal places? To 4. Yeah, it wants it to 4. So negative 0.6667. Okay? Alright. Okay, here's the one, easiest one you could do that people had some questions on. This is way easier because your calculator does it all for you. This is easy because your calculator wants to give you the answer in standard form, and that's what we're asking for. So if you're given 3 random points, nothing special about them, and you want to find the quadratic function, the parabola that goes exactly through those 3 points, all you have to do is regression. Questions?
Doesn't the calculator do the other one too?
Okay, it does, but if you do the other one, the problem is, it will do the other one, but it's not going to give you the answer back in intercept form. However, you might outsmart the question here because A is the same in both of them. Right.
Okay.
And so it actually will give you actually could even use the calculator on this one. Now, if they'd asked, does that make sense?
Yeah.
If we had to write the whole function out, it wouldn't help you because it's, we want the function in this form, just to plug in A and P and Q. But if you're just looking for A, you could. So all we have to do on this guy right here, if I want to come up with the quadratic function in standard form, is just go on my calculator. Yeah, good. I'm just going to go back and do the same kind of regression stuff we did with all the linear regression stuff. So I'll just go stat, screen, edit, and I'm just going to put in, let me clear these. Yeah.
What were you doing?
I have no idea what that was all for. Oh, I know what it was. I was calculating some medium mode stuff for a different class. So then, I'm going to put in these 3 ordered pairs. So -7, 2, and 7 are my x values. Corresponding y values, -7 goes with 9, 2 goes with -5, 7 goes with 12. Good. So I got them all in there, 3 ordered pairs. Now I just do regression. So stat, calc menu, quadratic regression is number 5. And if I hit enter, it's going to give me the answer. So y equals ax squared plus bx plus c, where a is that decimal, b is that decimal, c is that decimal. Which one are they asking for? They're asking for a. So it would be to 4 places, it would be 0.354, right? Okay. And I don't even need the 0 there. Right? Okay? All right. Last one. Okay, this is one we went through recently. Remember, this is the one where the calculators are really helpful whenever it doesn't have to be for quadratics. This will be very helpful in upcoming chapters too. If I'm trying to solve some kind of equation with variables on both sides of the equation with a graphing calculator, all I have to do is just make 2 different equations and intersect them. I'm going to call this side y1 and that side y2. I'll graph them both, I'll intersect the 2, and I'll find whichever intersection they want. If they want the greatest solution, that means, for us, that means the right intersection, right? The least solution would be the leftmost intersection.
Yes.
So we just go back to our calculator. Just go over here so I can see. And first one, I've got 3 times the quantity, x plus 10 squared, is 10 squared plus 3. Second one, I've got 9 times the quantity, x plus 3. Squared plus 5. Okay, so if I go to, I'm going to start off just going zoom 6, we'll just see what happens. There's one up there. I can't even see, oh, there's the other one. Okay, so I'm not seeing the intersections there though, am I? Where do I want where would I want to go off the screen to see where these intersect?
Up.
Yeah, I'm gonna go kind of up here maybe.
Yeah.
Does that make sense?
Yeah.
Okay, so I wanna set my screen to be different then.
So can't you just like set it somehow so we just look at that quadrant?
I'm gonna try the trick you guys showed me. I'm gonna try to zoom out up here. Okay, so if I go zoom out, and then I'm gonna go, this is a good trick, I had no idea about this.
Good job, Kate.
So I'll just kinda go back over here and I'll put my cursor up here, and we'll just see what happens. And zooming out's good here because then I can see more of the screen, right? So let's just try that. We'll see what happens. So if I hit enter, let's see what we get. There's one. There's the other one. Okay, it's getting there, but not quite. Right? So I got to go up some more. Okay, I'm just gonna try that again. I'm just gonna go up here and go zoom out. Enter. Okay, now when I'm zooming out, it's making them a little too skinny though. How can I fix that? If I went to the window, how can I fix that so it's not so skinny?
Fix the.
Yeah, I don't have to have my X min and X max be so far apart. What if I did like negative, I don't know, negative 15, positive, I don't know, 10? And let's try that graph. Okay, it's getting there. Now it's getting there, isn't it? Can you see that it looks like these are going to intersect up here, doesn't it? Right?
But they won't.
So if I go, I'm going to make my Y just a little taller. Y maximum, how about if we make Y maximum 400 or 450, we'll say?
You went way far down. You didn't put it in.
Did I mess up?
You put it in the X
What did I do?
something.
What did I do?
X
Oh
max.
gosh. What am I doing? So that, what do we have that as, like 10, 5, something like that? 10. So Y maximum, I'm gonna make 450. Yeah, I bet we'll get it. Almost. We gotta go up a little more. I'll make it.
672. That will work. I
This is,
promise
but you see how this works? I mean, this is no easier for me than it is for you. I'm just trying to get this thing so I can see it. So I'm gonna make. I'll go 900. That ought to do the trick. Oh, that's gonna do it. Ah, right there. Okay, so do you see them?
Yeah.
We got intersections there, and they wanted the greater intersection, the greatest, right? The greatest solution. So all I gotta do is go up here and find that intersection. So second, calc, intersect, and I can hit enter twice, and then just go make a guess.
What was that?
Okay, so let's just try that, see if that does it.
Just start the yell.
Oh, see, it found the wrong one.
Click, click.
See, it found the wrong one, so I gotta go.
But if you hit enter again, we'll go to the next one.
No, unfortunately it won't. But I can type in an X value. This will be quicker. So if I go second, calc, 5, enter, enter. But instead of, for my guess, instead of having to trace over, because that's so time consuming, I went from X equals negative 15 to 10. So if I pick something like 8, that's going to be a pretty good guess, right? Now it'll go over here and find this guy. We got it.
You could have done that the whole time.
Okay, so then my answer is, I want the X value, because my original equation, I'm looking for, has X's in it, right? So the X value rounded to 2 places would be 6.53. There it is.
Easy squeezy lemon squeezy.
Yes. All right.
You wanna fucking-
Yeah, I'll tell you what, we'll
Tell us the pirate joke.
Pirate thing.
pirate thing.
Pirate
Okay.
joke.